Hello. This is going to be an audio class run by me, Durmu. This, again, was just something that has come about just because a lot of people in the community and everything has started streaming themselves at different times, me included. And because of that, like, we all didn't really collaborate and like convene and talk about like, you know, setting up our audios and everything like that. So we all have very different audio settings. Not that that's like bad or anything, but I do know that there's a lot to improve on amongst like everyone's audio, especially my own. So I think just like putting it out there just to see like what is like some basic audio concepts, things that we should keep in mind can really help the way that our audio sounds and like really fine tune the way that we want our own audio to sound on stream, and even in just on the things that we do offline as well, like with basic recording as well. So again, just wanted to get out there that this information is widely available. So none of this is my own original information. This is like things that people have figured out time and time again, science, audio engineers, everything like that. So I'm gonna have some references in the description of this video wherever it gets uploaded of some people that information that I did reference from. So just want to put that out there so I'm not plagiarizing or anything. But let's get started, and then we're gonna start with some basics. So today's lesson is gonna go from hardware, things to keep in mind for like hardware choices, because your best audio starts at the equipment that you use. And then we're gonna go into using that hardware properly. So the way that you use the hardware, position the hardware, everything like that. And then once you actually are recording your voice and your audio, what can you do post-processing and like software and everything to make sure you are outputting the cleanest and the best audio that you can. The first thing that you guys want to think about is your hardware. So hardware, there's a lot of things to consider when it comes to your hardware. Obviously, one of the most important things to consider is your microphone. So your microphone, again, is one of the things that like is going to be super important for determining whether or not you have a good sound that you want. So there's a lot of places to start when it comes to thinking about the hardware that you choose. For example, there are two different types of mics. There's a dynamic microphone, and then there's a condenser microphone. So those terms get tossed around a lot. And for those who are not really particularly into like looking up like really detailed audio stuff, those terms don't really show up a lot. So all microphones, essentially the way that they work is they take sound waves to vibrate a component inside the mic called a diaphragm. And when that sound wave vibrates that diaphragm, it generates electricity, and that electricity is then amplified within the mic to essentially generate a mic output. So now, why is that important, and how does that affect dynamic versus condenser? Okay, so there's a lot under here, a lot of complexities under here. So I'm trying to give it the most simple explanation that I can. And I'm really trying to give it super basic. So I'm probably skipping over a lot of important concepts, but I'm trying to get like the big main ideas here. So a condenser mic is higher sensitivity. Now, what does that mean? A condenser mic means, when I say higher sensitivity, that means that it is more sensitive to the sounds that you speak into it. So that means that you can be further away, you can be on an off angle, the mic can be in a different position, the mic can be like on your desk a little bit further away from your mouth, and you can even have the mic not completely in frame, and that will still pick up your voice very clearly. It's a really good option for if you want, like it's a really good option for things like vocals, for example, just because like you don't have to worry about like really precise positions. It's really good just because like, especially with the way that our voices work, with the volume that we generate and everything, like it's good to be able to have flexibility when it comes to the way that you speak. And you'll often see that a lot of the mics that are marketed towards like general use, like gamers, streamers, a lot of them tend to be condenser mics just because it allows for a lot of flexibility, right? A lot of times, like people don't want microphones right directly in their face. Like they want their setups to be clean and their images to be clean, so they can have like a mic like further off in the distance, but still pick them up very well. Speaking of mics that are directly in your face, we have things called dynamic mics, which is actually this mic that I'm using right now. So a dynamic mic is lower sensitivity. And because of that, like you have to be pretty close to the mic in order for it to actually pick up the sound. So because of that, you could actually infer then that if a condenser mic can pick up signals that are further away from the mic, that means that things like electric fans, ACs, background noise, general talking in like another room, general talking in the same room, a lot of that stuff can be picked up. However, for a dynamic mic, that kind of fixes that issue on the hardware level. Because the mic is such low sensitivity, you really have to speak directly into this mic in order for you to actually get the signal and get picked up. In fact, I actually have a setup right now that actually boosts the gain of this mic a lot more than it usually does out of the box. Because if I didn't, I would actually have to be much closer to the mic, like almost actually kissing the mic in order for the signal to come through properly. That's like the big difference between a condenser and a dynamic mic. We can go into like inside what makes the difference, but the big difference there is condenser mics are much higher sensitivity and dynamic mics are much lower sensitivity. So if you want background noise cancellation, like at the hardware level, I would consider a dynamic mic. But then that requires you to be able to have a setup that allows you to have a mic very much closer to your face. Because of that, like I actually have a boom arm. So this boom arm allows me to move my mic different positions and allows me to put it in front of my face, and I can be completely free to do it. So, and also clears up all my desk space. So that allows me a lot of flexibility when it comes to my setup. Those are the big differences between a condenser and a dynamic mic. But now there's another term that gets tossed around a lot that is up for debate for a lot of different streamers and a lot of different just like people in general. And that's the debate between using an XLR mic and using a USB mic. What does the XLR and USB mean? So that refers to the input for the mic. So this is my old mic. You can see the back of this. You see this little like 3-pin hole over here? This is actually XLR. And then obviously everyone knows what a USB is. So why is there such a debate between USB or XLR? So XLR has been a very like traditional like input and like input method for like audio, like raw analog audio. Just because it's a balanced sound. It has 3 prongs. It has a ground. It has 1 prong for a signal. And then it also has essentially that signal, but like flipped. Because it's exactly flipped, it cancels out the signal once it's going through, which essentially cancels out any noise that it might also have as well. One of the things that you guys are going to learn at the end of this is that there is no right mic to have. It all depends on your setup. So the USB is obviously the most convenient, right? All of our computers have USBs. Most of our devices have USBs and everything. So it's probably the most universal, most like easy way to use something. It's literally like just plug and play, right? And what's awesome about USB is that it could bus like power. So like you could, like that's the reason why like you can charge your phones via USB, right? You just plug in like a cable into your computer, and then like it can carry like that electrical signal to bus power, and it can also like transfer data over that cable, which is really cool, which leads to a lot of really cool things that USB mics are very unique for. Okay, so then what else is the difference between XLR and USB? Well, XLRs carry like an analog signal, right? So because it carries an analog signal, which essentially there's a big difference between like analog and digital signals. The only thing that you need to know is that the analog signal is like a raw signal that comes from like the actual movement that the sound waves that you speak into a microphone and like generates vibration. So it's actually physically causing like that movement, which is like we can consider like an analog signal. And the digital signal is it just has to do with like that signal being transferred over as like ones and zeros and everything. That's all you really need to know about it. We don't need to get like super into that. Like there's no need for us to get into that. That's just like, think about it as that, and you can leave it at that. So the main thing that you need to know is XLR transfers analog signals and USBs can transfer over digital signals. Now, why do we need to know that? So because it's transferring over as an analog signal, our computers read digital signals. So that's why when you plug in a USB cord into your mic and then you plug it into your computer already knows how to pick up that sound and pick up that audio because it's digital. However, if this XLR mic is transferring over an analog signal, we need to do something to that analog signal to convert it to a digital signal. That's what we call a DAC. So a DAC is a digital analog converter. So there's a lot of devices that can act as DACs. The one that I use personally is called an audio interface. The audio interface is essentially this box that's another device that like sits on my desk, and then you plug an XLR cable into the box, and then the box outputs as USB, and then you plug the USB into your computer. So now it transfers that analog signal into the box, it converts it to digital, and then it outputs it USB into your computer. And now you have an analog signal converted to digital, but you still have all like the benefits of like analog signals going into your computer now. What's cool about USBs is that USBs are super smart. Since they can carry data and like all that type of stuff, there's actually an interface, essentially a DAC inside your USB cables anyway. So what are the pros and cons of XLR and USBs? You will typically get a balanced sound from XLRs because of the 3-pin construction that they have. So a lot of times, like if you get noise, it's probably from something else, but it's not gonna be because like your mic is like unshielded or your signal is unshielded and everything like that. Like you're gonna have a really balanced sound coming from your microphone, which is really great for your audio quality. There's lots of information captured in that signal, which is great for like post-processing and editing. And also, like people don't consider this, but Windows does not know how to accept multiple USB mics plugged in at one time. Windows can only really support one mic at a time if you plug it in via USB. It doesn't know how to register multiple input devices. In fact, that's the whole reason why, like, if you go into like different applications, like you can only select one mic at a time. And then if you plug in another mic, your computer kind of is like weird about it. So especially if you're going to be doing something like a podcast, or you want to have a multiple mic setup for whatever reason, you actually can't do that with a USB mic. One USB mic at a time typically is the way that Windows behaves. So my audio interface, for example, and a lot of other interfaces have multiple XLR inputs. So for example, if Azen and I wanted to do Moo and Koo on one computer, what we could do is I can actually plug in my mic into my interface. I can plug in Azen's mic into my interface, and then we can record on the same computer, and I could just do it on separate audio tracks, which is pretty cool, because that way you get really clean audio and you can have multiple sources of audio, and you can all do it on one computer. But with a USB mic, it's gonna be very difficult. Cons, you need an interface. So that's another thing to buy. So if you're trying to save money, I would say typically, like, if you investing in all this stuff is really good, and it's worth it down the line because everything is much more higher quality and will last. But that is, you know, an initial thing that you need to buy up front. And there's not a lot of features. XLRs are audio cables, you know? So because XLRs are audio cables, like that's pretty much the only thing that really gets transferred over is just audio. There's a little more caveat to that, which again, don't worry about it. We don't need to talk about that today, but typically you'll see that XLR mics are literally just mics. Like you can't do it. I have no buttons on this. There's nothing to do on this. So what's cool about a USB mic? Well, USB mics, like I said, they transfer data and like power over very well. So because of that, USB mics have a lot of really, really cool features. They have buttons and like they have like things that you can interact with on the mic itself to like mute the mic. You can turn the gain up directly on the mic. You have like a touch surface that like you can adjust the volume, and like there's like lights and everything. Like it's really cool looking for like a custom setup. The power that a USB buses from your computer is powering that mic to be able to do all that types of bullshit, which is really cool. So if that stuff matters to you, about like convenience, about like, oh, I can tap my mic to turn off the gain, or like to mute it real quick, or I can have like shortcuts and stuff on my mic depending on whatever mic that you have, you're going to want to use a USB mic. It's really cool and very, 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 very easy to use. Just plug it in. Now, what's the cons of that? Well, because a USB mic and like USBs in general have everything kind of just built in terms of like the DAC and everything, companies tend to cut corners on some of the hardware that they use for USB stuff. I would argue that there are some things, especially when you put it up against like real, actual like audio heavy use cases for like singing and vocals, you're gonna start to realize that USB mics kind of fall short because of the information that signal has is very lacking compared to something like an XLR, especially when like you have a really, really nice DAC that exists in a dedicated audio interface box. You can have some drop off in quality. Your signal might not be very clean. There might be some noise. So that stuff typically is important to you, that might be something to consider. However, how important is that stuff? So the question that people tend to ask is, what is better? What should I get? Should I get a USB mic so it's for the convenience, the plug and play factor, the really cool features on the mic? Or should I get an XLR and like invest in an audio interface and do all that type of stuff? The real answer to that is that it depends. I'm not gonna sit here and be like, oh, you really have to get an XLR mic, so you really need to invest in an audio interface and do all this type of set everything up, get a boom arm, all that type of stuff. I don't think it's completely necessary. I would argue that like for like 95 to like 98% of people, especially for just like streamers, a USB mic will do everything that you need. USB mics are great, especially these days. USB mics are very, very good. Like sometimes you won't even be able to tell. There are some people who podcast that we know in the community and everything too that currently use USB mics to podcast, and they sound wonderful. And even so, like they sound better than like when I use my XLR and everything, just because like the way that you post process and everything is like very, very important, and the way that you position your mic and you use it is very, very important. So honestly, if you already have a USB mic, I would say keep it. Like if you're not like ready to spend money, or you don't want to spend money right now, just use your USB mic and you're going to be perfectly fine. However, I will say that you have a lot more room to grow, and you have a higher ceiling of better equipment out there if you do decide to go the analog route and you get an audio interface, you get an XLR mic, everything like that. But I will say your USB mic works perfectly fine. You should get a dedicated mic no matter what. That's the end of the story. Don't use a built-in mic, your laptop mic, your webcam mic, your phone mic. Like you might have, like the least that you can do is get a dedicated mic. And also get a good USB mic. Don't get a run-of-the-mill basic USB mic. You might as well get a good USB mic. But then that leads into the issue that a really, really good USB mic is probably more expensive than your at least good XLR mic. A HyperX mic, I believe, like the Quadcast S, what is that? Like $140. A Blue Yeti, $120 maybe. I might be messing up these numbers. This mic that I'm using right now is $100, and it's wonderful. I love this mic so much. So now the next part before we move on to post-processing and software is, what is the thing you want to consider before that? And that is the recording process, the physical recording process. What do you need to take note of? So one of the things you need to take note of is where your mic is positioned. So if your mic is positioned low like this, and I'm talking down into my mic, my audio will probably sound a lot darker and a lot lower than what is usually my usual talking voice. That's good for certain applications. That's good for like podcasting if you really want to sound super boomy and everything. You want to sound like a radio announcer. But if you actually raise your mic a little higher, maybe you want to put it a little higher like this. This is forcing me to talk into my mic, which is actually elevating it, and the muscles that I use to talk are actually positioned better. So I actually have a brighter audio. Something like that is really important to consider depending on what type of sound you want to provide. If you have your mic, especially even if you have like your mic on a desk right now, you talking into the mic like at your desk like this is going to affect your tone, especially if you're bending over to talk to it. But if your back is straight, your mic is high, you'll have a brighter sound. And if you're lower, you have a darker sound, all that type of stuff to consider. And now you got to consider these other things called plosives and sibilants. So plosives are essentially the sound that gets picked up by your mic when you say things with a P sound, with a popping sound. So that's why it's plosive. If plosives really bother you, then you got to position your mic in a way that will eliminate your plosives. So yeah, a lot of people are bothered by plosives. So how do you get rid of plosives? So bear with me here. I'm going to talk directly into my mic like this. So when you can probably hear my p a lot more distinctly. One of the easiest ways to get rid of plosives is to just offset your mic, just like that. Another thing is your mic distance. If you want your mic to be further away, that's going to be better for like not peaking your mic. Also, like you're having a windscreen. So having like a pop filter or a windscreen or a shock mount to absorb, like, for example, I don't have a shock mount. There is an internal one, but because I don't have a shock mount, if I like slam my desk, you can probably hear that. So if you have something like a shock mount, it actually like stabilizes it. So if you like slap your desk or like you move it, it actually doesn't pick it up. The boom arm allows me to like have all this space underneath me, which also suspends my mic in midair too. So I don't have to move my mic a lot, and moving my mic causes more disturbance as well. But having a mic stand, like having that on your desk, if you hit your desk, the vibrations will get picked up by your mic stand. So the boom armor is actually better at negating that. But we're gonna move on to post-processing. What are some of the things we got to think about? So we got to think about your levels, right? So your levels are going to be louder depending on how close your mic is, your position of your mic, everything like that. Your levels are essentially your volume levels. That's what I mean by that. So I would say your volume levels, again, there is no prescriptive all answer to that type of question. The answer is always it depends, but I can give you general guidelines of what I do, and then you can go off of that if you want. My preference for my vocals is to be at like -16 to -10 decibels. This is my OBS. I'm peaking at like -8 or so, but I tend to talk. I'm actually talking a lot louder now, so that's probably the reason why I sound louder than usual. But you can see I'm actually like around -10 to -15, depending on what I'm talking. If I'm talking a little bit faster, then sometimes it's going to sound a little lower. If I talk further away, I'm going to sound a little lower. Typically, I like to have my vocals around the -15 to -10. I think that's a really good volume because your vocals should probably be at the front of everything. Your vocals should be like obviously one of the most important parts of your stream. You're the one talking. So now what's next? Your game audio. Your game audio, I like to have my game audio at like -25 to -30. So whenever something plays, I like to have that there because it will be behind my vocals. It won't overpower my vocals. Of course, sometimes it will. That's why you got to adjust. But I typically like to start at my game audio around -30 decibels to -25. And if I have background music playing, maybe when I'm chatting or something like that, maybe I'll keep that a little lower, -40 to -35. Just general suggestions. There's definitely not like a right or wrong there. That's just like what I would do. So, but you know, of course, do it at your own discretion. That's just my stuff. But what's the most important thing to consider when it comes to your audio is do not clip. And what do I mean by clipping? I actually can't clip right now because I have a certain filter on. But when you clip, you actually max this out. So right now you can see I have a very clear green bar and I have a very clear yellow bar. But like if you speak really, really like very, very loudly, this entire bar turns red, and that's not good because what that does is now like it's clipping and your audio peaks out. And then you actually lose your signal. Like you lose information in your signal because you're overloading your electrical signal with so much information because you're screaming and you're yelling that you actually start to degrade the rest of the signal. And when you try to edit that in post, you just have a distorted signal and you'll lose all of like the vocal info underneath that. So screaming, obviously, there's not a lot to see there. But if you're just talking really, really loudly and you're clipping, then what's going to happen is you're actually going to lose some of those words and like your clarity because all your audio is getting distorted. OBS has the feature that you can actually use filters to help improve your audio. Now, what does that mean? So there's a bunch of different things. So for those of you that are familiar with audio things like plugins, like audio production, there's these things called plugins that we use to kind of like add effects and improve our audio. So this is essentially what this is. First, we're going to look at this diagram here. So this is a sound wave. So when you actually record, a signal, like when you record something and like you see like yourself, you see your audio form when you talk. So what is it? So this is a sound wave. And now one of the big things that we're going to be looking at here is this big blob right at the front. This is called a transient. A transient is essentially this really short, high burst of just amplitude in your audio signal. So they typically exist when you first start talking, because like when you first start talking, you start to level out the way that you speak. But especially for some things like plosives and everything, that initial burst of like that sound is called a transient. And transients are usually the thing that really troubles people's audio because like transients can be very high, and then like when you start boosting your gain, those really like unfavorable sounds start to boost with it in your transients. So how do we fix your transients? With a compressor. Now, a compressor, I don't know if you guys have ever heard of what a compressor is, but a compressor, essentially what that does is it compresses your audio signal. So it lowers the highs and it raises the lows. So as you can see here, we have another like waveform with a transient here. What does a compressor do? So there's a couple settings here. So I'm actually going to open up my compressor and I'll show you what it looks like. So my compressor is actually not the default OBS compressor. I have a pinned message that has like a third-party like audio effect plugins. I highly recommend them. They're great. because the ones in OBS have no visuals to them, and like visuals are really important when it comes to this type of stuff, and also just helps. So we have a couple of settings here in a compressor. So you can see here there's this thing called a threshold. Now what's a threshold? A threshold is essentially the decibel level that the audio has to hit in order for your compressor to start compressing. This is on a scale of volume of like decibels. This is like an X amount of decibels that your volume has to hit before the threshold can start. I would determine that based on when you normally speak, how loud do you usually go? For example, I actually set mine here. This is funny because I set this when I was actually like Aislinn was in the middle of doing things. So my compressor is actually a little aggressive right now. What does that mean? So as you saw earlier, I was talking at like, typically I was talking at like -10, right? But I have my threshold at -12. So typically what you want to do is you want to see your usual range of volume. So I thought my usual range of volume was like -20 to -15 because I think I was talking quieter when like Aislinn was in the room with me. So I'm around that. So then what I did was I set the threshold to a little bit above my max volume that I usually speak at, because that way, if I start to go louder than I usually go and I start to get excited, I start to yell, start to be more excited, I want my compressor to come in and I want it to start compressing that higher transient sound so I am not clipping my mic. So what you want to do is like just talk normally as if you're streaming, as if you're just like in a conversation, and see what your normal volume levels are. And then just you see the loudest volume that you go, just put your threshold just a little bit above that. That's what happens when a compressor activates, right, with a threshold. But what exactly does the compressor do though? Like what happens after it hits the threshold? So the ratio is actually what the compressor does. It's the amount of compression that's applied to the waveform once it hits the threshold. So we're going to look at this, right? We're looking at the area above this waveform, right? So let's say that this top is at 12. So a ratio, like it sounds like, it's a ratio of two numbers. It's a division. So if you set your ratio to 3:1, right? That's a very common setting. People do 3:1, 4:1. That means that once it hits the threshold, you will start to compress the signal above that threshold at a 3:1 ratio. So that means if we're at 12 right now, this decibel is at 12, this is going to be essentially divided by 3. So we're going to bring it back down to like a third of it, to like down over here. And that's it. That's like the easiest way to explain what the ratio of a compressor does. And that's pretty much it. It just compresses the really tall signals and everything. It helps to like really improve your dynamic range of your audio. So now the next option to look at is your attack and your release. The attack is how aggressive you see how it's like measured in time, in milliseconds. So this is the amount of time it takes for your compressor to kick in when it's time to start compressing. So it takes 7 milliseconds to do so, and the vice versa, the release. So when it's time to stop compressing, the release is how long it takes for it to release and stop compressing. If there's anything that you want in terms of like numbers to take away from here, then sure, like 6 milliseconds is a very common attack and 60 milliseconds is a very common release. The only other thing that you got to worry about is called the knee. So the knee is essentially this red line here, right? So this red line is my threshold. So if I activate a knee, you can see if I hit a linear knee, you can see this area right here becomes not as sharp, right? Because this is like a sharp 90-degree turn right here almost. You go linear, it's a little bit of a softer hit, and then it becomes soft, and now it's a fully curved line. Essentially what that means is that leading up to that 12 decibel threshold, it's a gradient. So as you get closer to the threshold, it's actually going to start the compression, and then once you get after it, then once you pass the threshold, it actually starts to make the compressor more aggressive until you hit the ratio. And then the same thing, it's like a gradient all the way up and down. So it helps to make your compressor sound more natural. And then the last part of a compressor is the makeup gain, which is essentially this output. By the science of a compressor, you're compressing these waveforms down, which means you're actually decreasing the volume of these waveforms. So you're actually losing gain by doing so. So the makeup gain is essentially adding more gain back to your signal after it's been compressed. So that sounds very counterintuitive. Why would we do that? Well, the thing is, if you added gain to your uncompressed signal, everything gets increased. So that means while this stuff gets louder, your transients also get louder. And we don't want that, because then it's gonna sound like all the stuff that we don't want is gonna be louder too. So when you compress your audio, you make it smaller like this, right? If you add your makeup gain back to it, it does that all evenly now. So now what you can do is you start to actually have a wider audio sound to it. Your voice, you start to hear things in your voice that may have not gotten picked up. So this is really important in things like, for example, like snare drums, right? When you have like a loud transient with a snare drum, you're gonna hear that initial hit. But then once you actually remove that transient and then you boost everything, you're gonna start picking up the rest of the sound of the snare drum when it hits. You're gonna have this much wider sound, and you're gonna start to hear more of the actual sound. So that helps with like giving you a really much nicer audio quality. It gets rid of the harsh stuff, and it also brings out the other stuff in your voice, or rather just your audio in general. So that's the reason why compressors are important. And when you add the makeup gain, you start to hear more things that may have gotten like lost in here because of the transients. So for an EQ, this helps to really fine tune the sound that you want. I'm actually gonna open my equalizer here. And as you can see here, when I talk, the shape of my voice has a very consistent shape. Even though I'm talking and like I'm saying a bunch of different things, you can see here that this is the shape of my voice as I'm talking. So because you can see my shape, you can see where these frequencies are actually existing in my voice. One of the most basic things to note about your voice is the fundamental frequency. The fundamental frequency is the lowest part of our voices. So if you see here, I have this like audio waveform here drawn out, and you can see here that the typical range of our human voice is 80 hertz to 20 kilohertz. So, and that's reflected here on the graph here as well. You can see that my voice is hovering around like 80 to 100 hertz, and stops at around like 20 kilohertz. So the fundamental frequency is the lowest part of our voice. So for people that have higher pitched voices, their fundamental frequency might be a little bit higher than mine, around like 150, 200, etc. But mine is actually at, mine hovers around like 100. So what does that mean for changing stuff? So you can see I have labeled all these sections out by color. 0 to 80, there's actually not a lot of like voice info in the signal. So because of that, like we actually tend to apply this thing called a low cut filter or a high pass filter. What that means is that we cut out basically this entire region, 80 and below. The reason why we cut it out is because there's a lot of things that exist within that region, like AC noise, rumbling, background noise, fans. So if we just cut that entire region out, we won't lose anything in our voice because we don't have a lot of info there anyway. So that also helps for background noise. So now we get to the spectrum of your fundamental frequency, the 100 to 200 hertz range. Within the 100 to 200 range, again, like I said, because this is the fundamental frequency zone, this is where the lowest part of your voice is. So if you actually start affecting this region, you start to affect the boominess of your voice, because this is your bass. This is the lows of your voice, the lowest part of your voice. Let's do this in real time. So I'm going to start increasing it here, and you can start to hear that I start to sound a lot boomier, which is pretty weird and not very natural once you start getting like much lower sounds. But let's go the other way. And if you go the other way, the opposite of booming is your tinniness. So if you start to go the other way, it reverses it, but you keep going and you start to get a very thin sounding voice because you eliminate all the lows of your voice. So it sounds very tinny. I don't personally like the way it sounds, so if you think your voice sounds a little bit tinnier because of the way that your mic is, you can raise it up a little bit. So yeah, the next range are your mids. So for your mids, this is actually very interesting. I don't know how else to explain it. So I'm actually going to just say it the exact same way that I watched this in a video. They refer to it as boxiness. So for boxiness, it literally sounds like you're talking in like a contained box, essentially. Start boosting the mids, which I believe I set as, is it 3? Yeah, here. So this is this. So if I start boosting this, it starts to sound like I'm in a much more contained, close spot. Go the other way, you start to reduce it, and you start to sound like you're in a little bit more of a bigger box, like bigger space. Regardless, it's weird, right? I don't like it. I'm putting it back. The next region is your 1K to 2K range. So if you have a very nasally voice, or you're recording someone with a nasally voice, this is the area that you want to affect. I'm going to start boosting this, and you can start to hear that my voice gets really nasally, right? That's not even me with my allergies. That's just the way that the frequency sounds when you start changing my voice to make it sound like I have a congested nose. But what if we go down the other way? What if the person that you're recording, or maybe you, have your own nasally voice? Well, we can actually eliminate the nasal by going down in this frequency, and you can start to hear that you eliminate that weird nasally sound. So if you have someone that has a very nasally voice, you can actually counteract that in an equalizer by just completely going down in this region. And now it gets to this point where it's called sibilant range, which is like your S's and everything. So we talked about plosives before, but now we're talking about S's and sibilants. The sibilant range is 5K to 10K. So it's this last bit over here. So if I actually do the S sound, you can see that region peaks a lot more. That's where all that sound is. What happens in this region? Why would you ever want to boost your sibilant range? Well, let me show you the opposite way first. So I'm going to start lowering this, and then you're going to start to hear that my sound starts to get a lot more muffled. It sounds really weird. It starts to sound like I'm talking through a bag, I'm talking through a pillow or something. Very, very muffled, weird sound. If you want to counteract that and you feel like your mic sounds too muffled, you just got to boost it a little bit in the other direction, and you actually start to get a brighter sound. So if you feel like your voice sounds naturally muffled because of your mic or the way your setup is, if you boost this region, you start to actually sound a lot brighter too. You're also going to see on your plugins, you have this thing called dry and wet. That is essentially saying how much of the ratio do you want of your effects. So if I have 0%, which is completely dry, then none of the effects that I apply here are going to actually affect your final output sound. But if you will have it 100%, which is 100% wet, then that means it's going to be applying the max amount of that effect. The next effect in this is a limiter. So essentially it's a hard cutoff at a certain decibel. I was actually showing you guys that my audio was stopping at a certain level before. Why is it stopping at a certain level? It's because I actually set it at that. So my limiter is actually at like -8, -9 right now. So that means no matter how loud I scream into this mic, it will never go past -8 decibels. Consider having a limiter if you don't want your audio to clip, especially if you feel like you are louder. And then a noise gate. So a noise gate, literally imagine a gate. So a noise gate essentially is a hard cutoff for sounds at a certain decibel level, but then it opens back up at another decibel level. So I'm going to show you that right now. If I open up my noise gate settings, you can see here my noise gate is closed for anything below -42 decibels. So that means if I'm typing, if I have an AC going on, I have a fan going on, but that AC is not louder than -42 decibels, my mic will not pick it up and you will not be able to hear it. That's very good for things like background noise, typing, just loud droning noises that you can control and know where the sound is. Other important part is your open threshold. So anything above -30 now, the gate opens back up so you can actually talk again. And you can actually, like, that's where your audio comes back in. There's also a noise suppressor. We can get into like a noise suppression. The thing is, like, noise suppression, like, that's just something that you turn on and then it's done. Like, there's no settings to go over that. You just turn it on, and if it works, it works. So now that you saw all those effects, what the last thing to consider is, what order do these effects need to go in? Maybe the actual first question that you actually are asking is, does the order matter? Is there an order? Yes, there is an order. Essentially, you have your compressor before all this stuff, right? What happens is, like, for example, if you have it before your EQ, what happens is now that like when you start raising certain frequencies in your EQ, you're gonna start raising some of the stuff that your compressor is gonna cut off anyway. That you might be raising some of the unwanted frequencies that you don't want. So that's gonna be like reversing your compressor. The same thing with like noise gate. The noise gate has some stuff there, like it's picking up like an AC unit, right? Picking up an AC unit. If you have the noise gate after the compressor, if you do the compressor and you do the makeup gain and you start boosting all your audio levels after you apply your compressor, some of those things in your audio signal that you might be boosting might be like the frequency that your AC is at. So that's why you want to do your noise gate and your noise suppression first, so you get rid of those unwanted background noises. And you do your EQ, so you get all the frequencies that you want of your voice that you change, including your low cut filters and everything like that. And then you compress, so you can get the dynamic range, and then you put your limiter at the end. So amongst all that, you do not clip at the end. What does ducking do? So ducking is the same thing as sidechaining. So you can see here, I have all my like sources rather. So if I sidechain to something, right? I sidechain my mic to one of these things. When I talk, that audio is going to duck out while I'm talking. And then it's going to come back when I stop talking. And that's something that's really cool. That's a really cool effect when you do something like drums and percussion and like EDM music and everything like that. But like, it can really get frustrating to like sidechain if you like set it up to like something like Discord, right? Where like you're talking with friends and you guys are playing games, and you want to capture everyone's voices. You're sidechaining your mic, so every time that you talk, your friends all drop out. All right, guys. Well, that's the entire lesson. That's pretty much it. I think that covers pretty much everything that we need to cover. Thank you guys for watching. If you have any questions, feel free to message me, or since this is going to be on YouTube or wherever, feel free to leave a comment. All the sources that I use for this video are also going to be in the description. Again, this is all science, so everything's already out there. So I don't claim to know any of this knowledge independently of like everybody because this is just like physics and how everything works in science. So there will be references in the description for all the stuff that I used, as well as examples of the equipment that I use as well. If you guys are curious about that type of thing as well, just to see how my equipment affects the sound that I have. Anyway, that's the video. Thank you guys so much. And I will catch you in the next video. Bye-bye.